Right, this is the last video for the summer, video 4. So this is, we're going to use a normal approximation for both Poisson and binomial to do an equivalent to a z-test. So we've got we're investigating this distribution for a particular thing, and we need to decide whether it's whether we can do it as an exact test or as an approximation. The reasons behind that we will come to in September. Just know for the moment your summer homework, they will both be normal approximations that you do in the last sheet. So if you can get past my bad typing that I will have to change at some point, but at least it gives you some amusement with 1% significance level and production and claim, you should be able to read this question. So first thing you need to do is work out what type of distribution this is. So we're saying there's a constant average rate which tells you it should be lambda, it should be a Poisson distribution. So the millionaire wants to test the claim that he has a number of faults of 0.02. So you need to find 0.02 of 3,000, which tells you that it is 60. So there's 60 faults during an hour. Is that right? Per metre. So we're going to test whether lambda equals 60 or is less than 60, because he reckons it's less than that. So we need to test that. So because it's less than, we know it's a one-tail significance level. And we're interested in what we've observed, which is the fact that we've got 40. So this can't be taken from table 2, because remember lambda, all this lambda is 60, doesn't happen. So we can use an approximation to the Poisson, which means we're looking for the normal. So if we do an approximation, we've got lambda that we're assuming is 60, and our standard deviation is going to be root 60. So we're going to do a z-test because we're doing a normal approximation. So you do it as x bar minus mu, so that's x bar, which is what we observed, minus the mean that we're testing, all over the standard deviation, which is the square root of that. We come up with this answer. We look up the z in the critical tables for a, what was it, 1%, so 99% gives us that value. We want it in the middle, and that's our conclusion. So it is just using our lambda, recognising that lambda is the mean and lambda is the variance, and subbing it into our normal style z-test. Okay. This is the alternative then, another one. So a rail company claims 40% of its trains arrive earlier than at a particular terminus. Check a random sample of 150 trains that arrived at the terminus showed that 73 arrived earlier. Investigate the company's claim. So from this you can see that we're potentially looking at a proportion, assuming it's not a normal distribution. We don't have a mean or a standard deviation. It's not a lambda, we don't have a rate. So it's got to be binomial. There are reasons why it's a normal distribution. One of them being that you've got a very big n and also a very big p probability that we're looking for. So I'll come to that in September, we'll see. So because it's a test at a 10% significance level, our h0 we're going to say that the proportion is 40% as they're claiming, and we're going to say he thinks it's greater than that, arrive early. So we're going to test that whether it's bigger than that. It is a one-tailed test then at a 10% significance level. Because it's binomial, again, we need to work out, we know what it is. We've got, assuming h0 is true, which is what you do with these tests, that's always the assumption, then our n is 150 and our p is 40%. So our np would give us our mean, but the observed that we got was 73. So we want to test if it's greater than 73. So n is 150. We can shove it into our z table. So we've got 73 that we've observed minus 60, which we think is true because n times p would give us the answer 60. And our variance is np 1 minus p, this one here, which gives us 36. It's the square root of 36. From that, you get this value, which is z. We test it against the z value as we would do normally in the z test, and we get this out. Okay, so a little bit more of a sentence would be preferred there, but that's fine, and in context, not just talking about p. So this should work for the last two questions in the second assignment, ready for coming back in September. So good luck and email me if you need me.